things at the same time.
Right. All the preparation, resources, textbook,
Yeah.
quiz. Yeah.
So are we going through the preparation activities? So begin by checking your answers from the algebraic simplification worksheet. And I just looked at that. It looks pretty simple. I don't know if we have like some trouble, some things we need to go through.
Right. How much of this do we actually want to do? I have to admit, I'm still recovering a little bit from traveling.
Oh yeah, I don't blame you.
We hit a standstill in traffic last night. I guess
Really? Where were you guys?
semi-truck overturned.
Wait, really?
Yeah. We were driving north
Wow.
on I-15. We
Jeez.
were driving from Arizona to Utah, and a semi flipped over, and it took them 4 hours to get him off the road. So
Oh man,
we were stuck for a long, long time.
that's crazy. What time did you guys get home?
Like 1 o'clock in the morning. And then I had to get up
What
at 6 to go to work.
Jeez, what part of Arizona did you guys go to?
It's by Phoenix. It's a small
Okay.
town called Glendale.
Okay, yeah. Very nice.
My wife's biological parents are there.
Okay, cool. Very nice. It was a well-deserved break, honestly. That's what I feel at least. But
Yeah.
Alrighty.
Where'd you and your fiance head?
We actually went to Boise. It wasn't too far away, but we had to in Salt Lake and then go back up. So it was like a big U that we did. And yeah, it was good. Her parents flew in from Arizona actually, and she has a grandma and some aunts and uncles that live in Boise. So it was a good week. So and a lot of food instead of college food. It was good.
Yeah. Yeah, as a college student, you get excited about Thanksgiving.
That's right. No, really. Yeah. All right. So let's see.
All right. Algebraic simplification. It doesn't look too difficult. I think I can do that while I'm at work.
Yeah.
I can probably figure all that out. So
nothing looks too complicated. There's just factoring, and common denominator is kind of a pretty easy. Well, except the last one, I guess when you're using x minus 3, x plus 4, and x minus 2, I guess I kind of forgot that you can multiply those instead. Yeah, everything else looks pretty simple.
yeah. So plus it comes with an answer key. We can always check our work with that.
Okay.
Extension problems. It only takes one case to prove something is false. Show that you from the following occasion. Man, I really cannot speak today.
It's okay.
I have been stumbling over my words. Prove that something is false. Show that the following equation is not an identity, and discuss why. Sine of 2x equals 2 sine of x. Well, I can tell you that it's not the same, but
no.
Not sure if I know how to prove it. Unless we just simplified it to opposite over hypotenuse.
So you would 2 sine. Equals 2 sine over x.
If you look at the trigonometry identities resource, In double angle identities, there's sine of 2x, just like it's written. And then it says 2 sine of x times cosine of x.
There.
That's the identity that we would use. But you literally could just say opposite over hypotenuse equals 2 of theta is 2 opposite over hypotenuse.
No. I need to text her right now. I'm going to text her right now.
Yeah. Thanks.
How would you prove that?
2 sine x, 2 sine x. Well, I guess you can always input x, like you can put a value in for x and it won't equal the same, but I mean, I don't know if we need to go through the trigonometric identities to prove it wrong. I think that's what they're looking for, but like if you, let me see if that's right.
What if you subtracted just one of the sine of x's from the other side? So what if we brought 2 sine of x over and subtracted it from sine of 2x? You'd be left with negative sine of x equals 0.
X.
Because technically they're a common denominator.
Oh, that's true. Yeah.
Right?
Yeah. So,
would that be the way of doing that?
And so negative sine x
would equal 0, but we know that that's not true.
Yeah, that's true. Oh, that'd be interesting. Yeah. Are we're submitting something for this, or is it just a video?
No, this is just a video. Honestly, identities has always been something I've struggled with. So I don't know if you feel the need to go through it. I do. But not tonight. So if at any point you want to stop, I'm all for stopping. There's only 4 questions.
Yeah.
Although question 2 is kind of long.
They both equal the same thing when you place x as the same value for each side, so it's kind of confusing.
Which one?
See, like I just put a random value for x. They came out as the same value, but like I think what you put is a good case. That negative sine x does not equal 0, and therefore it's not a function.
To make something an identity, it has to be true all the time.
Yeah.
I have to wonder if there's a condition where sine of 2x and then 2 sine of x would be the 2 different answers. Based on what we've already learned, we know that it's 2 different. It's what do you call it? 2 different transformations, almost. Because you have the amplitude in front of sine, where you have the b that's in front of x, the b variable, which we learned in like week 1 or week 2. So that's why it's not an identity, although it doesn't mean that sometimes it's not true.
say when it's not true then? Or explain when it's not true?
I don't know. It just says show that the equation is not an identity and discuss why.
All right, well, that was good. The explanation you gave is good enough for me. I think that makes sense. I can see how. I mean, they're not the same, and so for sometimes, for some problems, they could equal out the same, like I did when I put the same value in and it came out the same value, but
Right.
But it wouldn't be always true, so therefore it's not. It can't be a trigonometric function.
Right.
Okay.
I agree.
Alrighty.
Originally, when I started to look at it, I went to multiply everything through and realized I'd get the exact same answer.
Yeah, that's what I did too.
I was like, oh no, that's not it. That's not how you do it.
Yeah, that's exactly what I did.
I think that one's close, but it's not an identity.
Yeah. All right, we can go to number 2.
Yeah. Find an equivalent expression for sine inverse of tangent x.
Sine
Discuss each part. Make sure you understand the process. Let me introduce you to how this problem is answered in calculus. Sine of inverse tangent x. What are you looking for? Given that x is a side length, the output of tangent inverse is it should be an angle, right?
It should be an angle inverse tan. Oh, well, inverse tan is giving radian, and sine of that should be the angle, correct?
Yeah.
Okay.
It's the angle of opposite over adjacent. Would it just be the 90-degree angle that we're used to seeing?
So do we have a value that we can put in for x?
No, they don't give us a value. This is just a thought
Like
experiment.
Okay.
Given that x is side length, let's make x the bottom, draw a right triangle, have your hypotenuse. The inverse tangent of x, the opposite over adjacent of x. So it would be the opposite angle, right?
The opposite
The
angle.
opposite corner. Hi. Okay, I'll be in there real quick. So that would be inverse tan of x. I think.
Okay, so at the end we get an angle. What would the equivalent algebraic expression be? It would be.
Wait a minute. It's not an angle. It's the side.
Oh, it would be a side. You're right.
Oh, I
Maybe,
cheated. I looked down and saw that the next step was find the third side. And realized that I'm looking at this wrong. Okay. So you start in the center. You have inverse tangent of x, opposite over adjacent, which would be an angle. But then you find the sine of the angle, which is opposite over opposite over hypotenuse.
Which will be the side. Okay.
Which would be would it be the short leg Or would it be the hypotenuse?
So we get opposite over y of x sine.
Oh,
I would assume the hypotenuse.
opposite over adjacent. Duh.
No, we would have the hypotenuse, so we would get the short leg.
The opposite.
We would get the adjacent.
Because it would be 1 over opposite adjacent opposite hypotenuse. Which really just flips it. So you have opposite hypotenuse times adjacent opposite. You'd be left with adjacent over hypotenuse, which
So
is
cosine.
cosine.
Oh. So the equivalent algebraic expression is cosine.
Yep, I think I did that on accident.
Wow, that's cool. I did. That was cool.
Yeah, I did that completely by accident.
Well, it worked out.
And I
Okay,
still
so-
have no idea which part of the triangle we just found. You can now find sine of theta. Sine of theta equals. I actually don't know what they're asking.
They didn't give us how we would. Can now find sine of theta. Sine equals.
Oh, sine of theta, as opposed to sine of x. Originally they gave us a sine. Now they're saying now you can find the sine of the angle. Because we just solved for all 3 sides. So you now have the sine of the angle of x, right? Which would be, that would be the opposite angle, which is opposite over hypotenuse, which could also be written as, what are they looking for? I don't think I know what that question's asking. Unless it's cosine of x, would be the cosine of x would be the equivalent. Because that's what we just solved for.
Sorry, I don't know what happened there. It says
All
on the
right.
left.
I think I'm just about done. I'm not thinking very well.
Okay, if you want to be finished here.
I think the answer to question number 2 is cosine of x.
Sine theta x.
I think.
I guess that's. I never thought of it that way.
I don't know. I have no idea.
All right.
I'm not a strong enough mathematician to understand how or why that would work. But that's what we solved for, and that's what we got.
Yeah. So I guess that is. I guess until we review this week, then.
Yeah, it
we'll
would
leave it at
help
that.
if we'd actually done the reading.
Yeah,
Sure.
I mean, I think it'll make more sense if we do. So this is fine that we're solving it before we even know. So.
It'll be interesting to see how accurate we are.
Oh, here's the key, though. Let me.
Oh yeah. I always forget that that's down there.
Given that x is side, the output of 10 is an angle.
Well, that's not at all what we got.
Sine x.
Well, we were right about the inverse of tan being an angle.
Yeah.
X squared plus 1 equals unknown. That's
Don't even know. Sine squared plus 1 over x squared root of x. I guess they drew it out, but I didn't know that we could use 1.
I think you and I stuck to identities. We weren't supposed to.
Yeah. Yeah, I think so.
But they did. They basically just did the Pythagorean theorem.
Yeah, to
Also know that sine squared of theta and cosine squared of theta equals 1.
that's right, yeah.
And it looks like they use that as part of their
Well,
art.
that would have been a little more helpful if we had that 1, I guess. But then again, I would have been totally lost anyways. But find this side, now we can find sine theta. Interesting stuff.
That's interesting. All right. I think I'm going to have to go over the reading before I continue. I don't know.
Hey, no worries.
So, cool.
Tomorrow, or are we just submitting this video in?
I'm just going to submit the video.
Okay.
We get the credit for the video, not doing the work.
Okay, yeah, that's true. Is William going to join us next time then? Is Brother Jordan the one that emailed you about him, or did someone message you? Okay, cool.
Yeah, I guess William lost all the members of his group as well.
Oh,
and it sounds like he's used to being the group leader, so he's asking if he can do it again.
Oh, well, very good. You get a break.
Okay with. But yeah, he's come on strong. He says that he wants to go ahead and schedule out all of our meetings, and
well,
we can do it.
All right, sounds good. Well, we'll just keep in contact for the next meeting then. It's Thursday night, right? When it's due.
Unless, can you meet on Wednesday nights?
I can. So Wednesday night will work for me. Probably around the same time, like at 9.
Okay.
And in most evenings, unless it's something comes up. But yeah,
Right.
most evenings are pretty open. So.
Okay. I'll talk to William. I'll give him your information so that all 3 of us can start talking. And then
Okay, sounds good.
we'll figure it out.
All right, hey, have a good night.
All right, you too.